Studies, of course, and for some reason I came across integration by trigonometric substitution for the first time, which is a bit of a, I don't know, I lay blame to probably some lacking in my early math education. But I have found that there's a lot of logical sort of skips over stuff and some thoughts that people might be getting stuck on this. So I thought, you know, it might be worth making a video in case it helps anybody. I have this little page solving it. I grabbed this from Khan Academy's video, Introduction to Trigonometric Substitution. Bit tongue-tied, sorry, it's early in the morning for me. And there's a few little issues I had with it. First off, I'd like to say it's a very good video. There's only a small number of things that I think it could have addressed. First off, why would you be getting a question like this? Mostly it has to do with when you're starting to create formulas in an actual coordinate space. So you might get a question something like this. Find the volume of, let's make it 90 degrees. Find the volume in a quarter circle, right? Or area, sorry. Again, early in the morning, you're gonna have to forgive me. Anyway, you could say find the area in this quarter circle, given that this is the y-plane, this is the x-plane, and the radius equals 2. Okay? Now, that's simple enough. But the teacher might ask you to solve this in Cartesian coordinates and polar coordinates. And that's where I think a lot of people get hung up on the trigonometric substitution, because you're trying to avoid polar coordinates deliberately, because that teacher has asked you to solve it in Cartesian coordinates. Now, clearly, sorry, stupid messages on my phone. Obviously, you'd start something like this by saying, like, you know, you got the whole circle, and then you want to parameterize it. And anyway, this is from like 0 to 2, that's from 0 to 2, but blah, 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 blah. But you ignore the domain for now, and you just sort of stick to the r squared equals x squared plus y squared. And then you get to something like, well, if r equals 2, then it's 4. That's 4 equals x squared plus y squared. And then you change it so you want to make y, you know, the equation dependent on y. Again, morning, throat. So it comes y squared, x squared minus 4 squared, 4, yeah. And then you take the square root. Okay, now let's say you integrate that, and that gives you the area of like the semicircle, but you'll be integrating, then you need to find sort of the domain there, but we'll leave that for now. So anyway, technically what you'd be doing here, I think, is a double integral, where that will become the terminal of the first equation at the top, yada yada yada, not important, because it's way out of focus for this. But anyway, this is how you end up with questions like this. And the reason that people would be avoiding the trigonometric solution is because it says solve for Cartesian and polar separately. There's 2 questions. Anyway, moving on. You see, though, that when I've done this, I've gone from a parameterized equation into a defined equation. And the domain is different for each of these. And so when Khan Academy assesses whether or not he's changed the domain, he's kind of started after you change the domain here. And you need to change the domain here between these two in order to develop equations that look like this. So I wanted to address that as like assessing the domain at this point onwards is kind of a trivial task, although he has done it because he's done something a little bit here, where he's actually changed the variable that the equation depends upon. And that's my issue down here. Okay, so first I need to have a little bit of an explanation. What you can do is with this equation is you can recognize that this formula sort of, yeah, that's different. It's not meant to be different. No, that's why I shifted y to the other side and then fall back, but that should make that negative y. Yeah, this isn't exactly mathematical, but you can see what I did wrong. So let's pretend. Anyway, so you can see down here that this is pretty similar to this, and therefore that should tip you off that here you have some information encoded in the x and some information encoded in the 4, and these two are related to one another enough that you can define the relationship as such. And you will see this pop up again and again. And I'm not recovering some of the stuff that Khan Academy's covered, but you can see here that if you got a unit circle, let's pretend this were 1, you'd have sine theta, cos theta. But we have a circle of constant radius 2, so it's 2 sine theta and 2 cos theta. And you would know that if you were given this question and asked to solve in Cartesian coordinates, because you would have taken this, turned it into that, and now you need to solve by trigonometric substitution, so you got to bring it back again. And that mixes people up. And yes, that's what your teacher is asking you to do. A little counterintuitive. So we come down to here to issue B, right? We've all seen x equals sine 2 sine x dx. Now, you're taking dx as something that doesn't have x in the formula. So I think a better way to write this would be x as a function of theta equals 2 sine theta. And that might actually help you with some of your hang-ups as well of doing that substitution. As such, now when we take dx, it's d dx of x theta equals, and you can see that it's a function there. But anyway, it's going to be, and then, right? Because that's your chain rule. That itself probably needs to be improved upon. But you can see the concept is going to be x as a function of theta, d theta. And that's what you can see here. There's one thing else I'd like to note here, which I think is interesting, which is your old little proof. Might be quicker for me to just pull it up if I've got it sitting around rather than redrawing it. I'm trying to keep you on the notepad because my room is a mess. It's a mess. Sorry guys. Just one sec. Here we go. Okay. Any derivative of a vector, right? Let's pretend for a moment that this is our vector. Any derivative of a vector with constant length is orthogonal to its derivative vector. Okay? So let's say you were looking at the sine function, but parameterized, so you'd have a vector which points to the surface of the circle, and its derivative, it may not surprise you, will be orthogonal. And here's a quick little explanation of that. To know the length of vector RT, this is just an exercise from one of my other books. Probably not very smart for me to just straight up and share it, but whatever. Moral of the story is, we should be comfortable with the idea of this sign going to cos in the dx, because it's going to be orthogonal. It's interesting though, because it means that the derivative of this is going to be orthogonal. So it's the integral. So it creates a bit of a complex scenario mathematically when you're restricting yourself not to work with vectors, and you're also restricting yourself to Cartesian coordinates. Okay? So it really demands that you do end up doing this. And the reason I point this out is because this looks like a conversion to polar coordinates. Yeah. And that's what was not asked for. Now, if I was some sort of math god, then I'd say that probably wasn't right. But if I were a math teacher, I'd be happy with that. Okay? Because really, well, a lot of the time, if the teacher's asking you to do Cartesian coordinates and polar coordinates, they're asking you to formulate the formulas as well, and then to write out the integrals. So by the time you get to actually solving the integral, they don't care if you then take your own path, which will probably involve going back to polar coordinates. And in all fairness, there is absolutely no way you could solve a question without like this without constraining yourself to the constraints of a circle. So no matter what you do, you're going to get something reminiscent of polar coordinates. And that's mostly it. But oh yeah, then you can see now where the d theta comes from, because technically what we've done is we've made this function dependent on theta. And in fact, might even go one further and say that. I'm not entirely sure if that would be valid, but this is addressing the things you might be getting stuck on, and I think that is enough information to get you through should you be having math block. Okay? Enjoy.